This talk is about building a framework for medical device security. I'm Jay Radcliffe, Senior Security Analyst for InGuardians. And kind of how I got here is I did a presentation at Black Hat in 2011 that talked about the human SCADA system. And as a type 1 diabetic, I wear multiple medical devices that are attached to me 24 hours a day, 7 days a week. One of them is an insulin pump. After doing some research, I discovered some weaknesses in that device and how it communicates wirelessly. And I was able to leverage that into being able to remotely suspend the pump, in addition to remotely changing any of the features and settings on the pump, which caused quite a bit of a stir up in the community and as well as in the medical community. I do a lot of work with different systems, different SCADA systems especially, power meters, the AMI, smart grid type of thing, but also traditional InfoSec stuff. I was employed at Internet Security Systems and IBM for over 12 years, and now I do consulting work through InGuardians. So the current state of research is progressing very rapidly in this field. The amount of research on medical devices has increased substantially, especially in the last 3 years. The focus being on embedded technologies, so insulin pumps, pacemakers, and implanted cardioverter defibrillators, which are inserted into the body right near the heart to restart the heart in the event that it becomes out of sync or stops working. Exactly what you would see on TV when somebody says clear and hits them with all the electricity that they can. There's also been an increased concern, though, over medical devices that connect to traditional networks and use traditional operating systems. And this has become quite confusing for medical providers as they go through the process of making sure that they're using these devices correctly, that they're maintaining security on these devices, but while also making sure the vendor will still support them and that they are still certified through regulatory bodies. And while this trend continues, that there are more research going on, there are still significant barriers that keep researchers from progressing even further. One of them is access to devices are very difficult. The cost is astronomically expensive. For example, the insulin pump I'm wearing right now costs between $5,000 and $9,000 US, and that's without supplies. And those supplies need to be changed every 3 days per the vendor. So for a company or for an individual that says, hey, I'm kind of interested in these medical devices, how can I get my hands on one to be able to do research on? The cost is very substantial. But not only that, access to these devices are restricted by prescription. So an individual just can't go out and buy an insulin pump. They actually have to get a doctor to say, here's a prescription because you're a diabetic and you need an insulin pump, in order to have access to spend the $9,000 US to get that pump. Now there are secondary markets that you can go to. You could buy a used insulin pump. You could buy a used medical device. I've purchased many of them on eBay, actually. But this complicates matters greatly. Device setup in many cases is very complicated, especially if you're talking about devices that go inside the body, right? Let's hope that none of us get a scalpel and go, well, let me put this thing inside of me so I can do some research, because that's probably not the best idea, right? Device functionality is a concern. How do I make this device work properly? How do I make it so that way I can see how it acts normally, as opposed to when we do research on it, trying to make it act outside of that specification? But there are also legal concerns here, right? You're actually, at that point, you have a piece of contraband, right? You have something that you're not legally supposed to have. It would be like having a prescription drug that you do not have a prescription for. There are laws against that, and you could be in prison for it. Most importantly, though, is a safety concern, right? A lot of these devices are used to keep human beings alive, but on the flip side of that, when used improperly, they can do significant damage to a human. In many cases, they can kill a human being. The electricity that a defibrillator gives out is over 800 volts, and that's certainly substantial enough to kill somebody. When improperly dosed, an insulin pump can put somebody into a diabetic coma and possibly even die. So that is also an additional concern and a barrier to this research. Nobody, when you get an email server and you start hacking on it and you break it, there's probably a very limited chance you're going to hurt yourself. But with these devices, the chances are much greater. There is substantial pressure to change, to make these devices more safe, to look at how they communicate with wireless technology, to look at how they interact on the internet. The United States Congress ordered an investigation to how medical devices are being looked at for software security. The GAO, which is the General Accountability Office, is the body in the United States government that does that research. And they did an investigation over a year and published a report in September that said essentially nobody in the United States, none of the agencies that approve these medical devices is looking at that. They're not looking at the software, they're not looking at the security, they're not looking at how it interacts on the internet, they're not looking at any of those things. They say that's the manufacturer's job at this point. We assume that because the manufacturer is working on it, that it's their responsibility to make sure that those things are safe. The report also suggested that that should change. They didn't say exactly how they would want it to change, but they did say maybe we shouldn't put all of our faith in the manufacturers to make sure these devices are secure. And security researchers are pushing harder for change. There's some researchers down at the University of Florida that are using Shodan that are showing the results of how many medical devices are connected directly to the internet, right? Adding to that, we can see more and more of these devices being added and directly accessible from the internet. There's also additional life-threatening research being shown specifically with implanted ICD devices and insulin pumps. Earlier this year, Barnaby Jack at IOActive gave a presentation showing how he could remotely engage a defibrillator and shock somebody with 850 volts. That is a very scary proposition to have to occur if you have one of these inside of you and that you depend on it for your life. How does government approval of these devices work? First, we're going to talk a little bit about how it works in the United States. So all of these medical devices go through approval, and they go through what's called the FDA, the Food and Drug Administration. And it has two unique processes for how it approves a medical device before you can buy it. One is called a pre-market approval. This is if you have a brand new device that's never existed before, and you apply for it and you say, hey, here's the device, here's what it does, and the FDA goes through and researches it. And when looking at these PMAs, the variance on how long it takes to get them approved varies widely. I saw some that were over 8 years. I saw some that took as little as 1 year. But generally they're between 1 to 4 years to get a medical device approval. And this specifically looks at the safety of the device. Is the device safe to use from a medical perspective? Focusing very much on the technology and how it interacts with the human body. And pretty much looking at it inside the scope of how the device normally acts, right? As computer security people, as computer researchers, what are we concerned about? We want to know how the device acts outside of its normal boundaries. Can I push things? Can I change the configuration to make it do something it wasn't designed to do? Can I make it do something that's inappropriate? How can I leverage it to do something that I want it to do rather than what it's supposed to do? None of that type of testing is being done by the FDA. But when you make a change to an already approved device, there's an add-on pre-market approval. So you can say, hey, I know this device has already been approved, but I made a slight change to it. And this could be as something as you switched vendors for supply in your supply chain, and that might be something that takes just a couple weeks to get approved, or you might be making substantial changes to that device, in which case it could take years again to go through the reapproval process. This PMA testing is much more robust. It is much longer to do, and it is much more expensive. The one you've probably heard a lot more about is the 510K, which is called a pre-marketing submission. And this is kind of an interesting little area, which you don't have to go through the full PMA process because you're claiming that the device is substantially equivalent to something that was on the market prior to May 28, 1976. So for example, let's say you are going to use an insulin pump, and the insulin pump existed before 1976. So you can say, well, because of that, I don't need to go through the full PMA, I can go through the 510K. And a lot of literature that talks about medical device approval talks about the 510K. This is interesting because it's not considered approval by the FDA, merely that you can market the product. It is a sales thing, primarily. And this varies also from time. It could get approved inside of months. It could take also years. And I'm not exactly sure, and there hasn't been much published on why exactly this takes a lot longer in different cases. The FCC also has a process, the Federal Communication Commission, that looks at the wireless communication of these devices. And we call this law Part 15. And what they are looking at is this device transmitting with appropriate power? Is it not going to interfere with consumer devices? Is the RF proper, meaning that it's not going to interrupt television stations, it's not way overpowered, it's within the legal scope of the law. Again, looking at these devices in the context of their normal working environment, in their designed procedures, not looking at them, how can I modify them, how can I tweak them, how can I make them do something they're not supposed to do. In Europe, it is a similar procedure. There is something called CE marking. And CE marking says that it has gone through an approval process, and there are many different types of directives that the European Union uses to look at these devices. Primarily, the Medical Device Directive 9342 EEC. Having read over this, there is no mention of security or communication, but specifically calls out software as a device. So if you have a piece of software that interacts with a medical device, that can be part of the approval process, but there definitely isn't anything looking at the security of that software and how that software is supposed to work, how that software can be tested to make sure that it's secure. There are two more directives that I'm going to mention: the Active Implantable Medical Devices Directive, which is 9385, and the In Vitro Diagnostic Medical Device Directive 9879. Both of these directives are great if you have insomnia, if you'd like to read up on them. They pretty much are very medical and don't have any relationship with how security and how communications work with these devices. It is almost entirely 100% medical. Class 3 devices, which are ICDs, the implanted defibrillators, and pacemakers, need individual country approval as Class 3 devices. This is a much longer process because each individual country has to look at these devices and approve them, which also substantially increases their costs. This is a chart on how you would get approval for your medical device in Europe. As you can see, you probably can't, because that is a very complicated flowchart on all the approvals and all the processes that you have to go through to get your CE mark. This is a big reason why it takes 1 year or multiple years to get that approval. We also have a big problem as computer security and computer scientists in classifying these devices. Right. The US and Europe have specific categories for devices based upon function, right? In vitro or inside the body devices and diagnostic are also, they also have diagnostic devices which differentiate in levels of risk, right? We know that an embedded defibrillator has a very high risk. You have to do surgery, you have to implant that, and it could also deliver substantial electricity to your heart to restart it. But some things are pretty mundane in comparison, right? Like a syringe. It's a lot less dangerous, even though it is dangerous, but there are different levels of risk. And that's how most of the countries and regulatory bodies look at these devices. And it's not very consistent between countries and regulatory bodies, between Europe and the United States. They look at the devices differently, they classify them differently, so they have to play by different rules. Unique to us, though, is confusion in the computer security field. Because there's a big difference between a device that's hooked up to an MRI machine that's running Windows XP and an in vitro pacemaker that has a proprietary platform. And the literature tends to dump all these together as medical devices. Right? When we look at medical device security, some people are talking about Windows systems that are in hospitals that are connected to medical peripherals. Some people are talking about the actual device itself, like an insulin pump, a pacemaker, those types of things, which are independent proprietary systems. So I kind of have these broken down into a couple categories. I would call category 1 any medical peripheral attached to a traditional computer system. This could be Windows, it could be Linux, it could be other commercial operating systems, but it is an off-the-shelf operating system. The scope of this is very wide. It covers a very large amount of devices. It covers more and more, and hospitals are using devices that have a Windows-based operating system or a Linux-based operating system on their devices. And one of the problems which many companies and hospitals have come to me about is they don't know how the status of patching and securing these software impacts the regulatory license of these. So if you buy a medical device from Acme and it goes through the approval process running Windows XP Service Pack 2 with patches up to date, and then 2 years down the road, the hospital says, well, this device in our pen test showed as being insecure. Can I apply patches to it? And Acme, the vendor, says, no, no, no. If you apply patches to that, that might, first of all, we would not service that unit anymore because we haven't tested that. But second of all, when you patch the device, it puts the regulatory approval in question. And that's why hospitals are very hesitant and vendors are very hesitant to say, oh yeah, go ahead and patch it. Go ahead and change the operating system. Go ahead and apply this patch or apply this security product and the device will work fine. They're not certain of that, so they don't do it. Also a problem is the lifespan of these devices are often longer than the lifespan of the operating system, right? You buy an MRI machine, you expect to keep that machine 10, 15 years. Operating systems don't last that long. So if you built your MRI machine based on Windows 3.1.1 and you expected it to last 15 years, when you get to year 5 and that's not supported anymore as an operating system, you're in significant trouble. There's a lot of good things about this particular device category. One is that there are a lot of eyes looking for the issues here, right? We've got a lot of research going on in the field about looking for vulnerabilities, looking for problems in traditional operating systems, right? Microsoft Tuesday, once a month, Microsoft graces us with patches to make sure that we stay secure. Right? So there are a lot of people looking at these problems. There are a lot of problems being found and corrected. There's also a very robust mechanism for applying patches and updates. Not only does Windows update itself if you let it, but there are a lot of commercial products which will help you manage very large amount of devices and the patch levels that they're at. And as IT people, we probably have great familiarity with these types of devices and how to apply patches and updates and make sure our devices are safe. Medical device category 2 is where we start getting a lot more complicated. These are independent medical devices. They run not commercial operating systems. They typically are embedded hardware running an ARM processor, a PIC, a system on a chip, things like that. And they usually run a completely proprietary code. One of the problems with these devices is that they're hard-coded. There's no method for updating it, right? When you implant a defibrillator into somebody's body, there isn't a USB port on their chest to hook up and flash new firmware to it. Even the ones that are outside, like insulin pumps, don't have a mechanism for updating a firmware. To update the firmware, you would have to do a full device recall, disassemble the device, remove the EEPROM chip, and replace it. This is a very substantial cost and a very substantial problem. An additional problem is that there's no independent testing going on, right? There are very few eyes looking at the problem. I mentioned the barriers to research. One of the only reasons that I was able to do research on an insulin pump is because I owned one and depended upon it because I have a medical condition that required it. Now, I wasn't able to do all the research I wanted because I couldn't break it, right? I definitely needed that device. I needed it to survive. But I could look at and examine the wireless communication without breaking it. So there are not many people looking at this purely because it's hard to get your hands on them. One of the things that I also see in these types of medical devices is do-it-yourself encryption and obfuscation. Vendors often believe that they are very smart. And they are so smart that they don't need scientifically vetted, peer-reviewed encryption, that they'll do it themselves. And they'll assign Bob and Alice over a week or so to come up with their own encryption and obfuscation methods, which are often pretty horrid. In the case of the Medtronic insulin pump that I looked at Black Hat, it took 6 lines of Perl code for me to de-obfuscate the transmissions. I wouldn't call it encryption because that would be insulting to the word encryption, right? There are some good things about this device category, though. The code base is a lot smaller, right? When you think about how much you have to look at on a Windows box or a Linux box or a commercial operating system, that's a lot of lines of code, right? There are hundreds, if not thousands, of libraries, DLLs, things that you can do, things that you can tweak on that. And that is a very large scope to be able to look at. Where with these proprietary devices, if you dump their firmware, if you look at their code, it's substantially, exponentially smaller amount of code to look at. So it's a little bit easier to get your hands around securing a device when you look at it that way. Also, these proprietary devices are much better equipped to support the full lifespan of the device, right? It's easier to have a proprietary system that's custom made that can last 10 to 15 years because it has that limited smaller code base. It only provides that one function, that functionality. It's not being used in a much wider scope of things. Category 3 would be devices that use wireless connectivity. This would include 802.11. Also, a lot of the vendors are going towards Bluetooth LE with their next generation devices, kind of getting small personal networks between 100, 200 feet of the individual to be able to establish low energy communications. And a lot of these use ICS, industrial control systems, or MICs, which is medical industrial control system, communication ranges, which are in the 400 megahertz and the 900 megahertz and the 2.4 megahertz range, or gigahertz range, to be able to do wireless connectivity for just point to point. So if I have a remote like this that communicates with my medical device, it's got a range of a couple hundred feet. I can say, give myself insulin, go, without having to interact with the device itself that's tethered to my body. I see this a lot with things like infusion pumps in hospitals, which is what you have attached to an IV bag that gives medication. The ones that I have seen have PCMCIA cards in them that do 802.11. One of the problems with these devices, though, is that there are no updates, and they're very slow to support new standards. I've seen hospitals that have entire separate wireless networks that can only use WEP encryption because that's all their infusion pumps will support. They will not support WPA or WPA2, right? Which is a scary thought, right? Your loved one is connected up to an IV pole that's only secured with WEP. Ugh, right? Not the greatest feeling in the world. And they often give them very creative names like infusion pump network, which lets you know exactly what the functionality of that network is. Right? And a lot of times the security mechanism here is through obscurity, right? Like very complicated wireless network names. So you have no idea what's going on in that network, or we just won't tell you so that way you'll never be able to guess it. We know how well that works. Also, there's very limited defenses with wireless, right? We all know this. We see our neighbors SSID being broadcast. We see in the hotel lots of people, and their SSIDs being broadcast, communication passing back and forth in the air. You can't put up a wall, you can't put up a barrier to that very easily. So there's access to it, even outside of your control. There are good things to wireless. A lot of these hospitals are in very old buildings, right? And they go to wireless because it's impossible or exceptionally cost prohibitive to pull fiber or Cat5 or Cat6 through hospital walls, through buildings that are hundreds of years old, right? You're not going to tear down and build a new building just because you need a new network. So you move to wireless. Sometimes that's the only option you have. So in that case, these types of things are good. Here is my big concern. I fear that regulatory agencies, because of the pressure, are going to go down the wrong path, right? The Food and Drug Administration is not equipped to handle security research. It's not their job, it's never been their job. These regulatory agencies are built around making sure the device is safe to use from a medical perspective, not from a computer security perspective, not from a communications perspective. Because they have no experience in security or how to regulate it, they'll go into it haphazardly and make it like other regulatory agencies that have gone into making things secure, which is to say, it doesn't do anything, right? They say, we say you should use this encryption, we should do this, you should do that, and we all know how well that works, right? Generally, regulators try and force security controls which fail to deliver device security. So we want to try to avoid that. Regulatory agencies should not legislate solutions, right? You don't want your government telling you what type of encryption to use, or how you should patch your systems, or how you should write code. That is never going to work, and it's going to get a substantial amount of backlash, and it's going to be problematic, right? More importantly, it stagnates innovation, right? Not allowing companies to develop solutions to their own problems. So a medical company might be like, I've got a really good idea that I'm going to patent or I'm going to develop that's going to have secure communication in a mesh network in a hospital. But the regulators and the government says I can't do that because I need to comply with PCI-like standards for my medical devices. So companies are not allowed to innovate, which would be bad, right? There's also zero infrastructure to support this, right? Is the FDA going to go out and hire 1,000 researchers to research all of the medical devices that use a computer system to look at the security? No, right? There's already a tremendous shortage of people in security, right? We see it in the paper all the time. We would like to hire about 10,000 new computer security experts for cyber war or for whatever, but there just aren't the people qualified out there, right? So even if they wanted to, and even if they had the funding, they wouldn't be able to get the people to do it, right? We also want to look at what's happened in the past. Look at the failures of other regulators. PCI is a great example of this, right? One of the biggest jokes in the world is PCI has made us safe. We're PCI compliant, so that means everything is safe. We all know that that's not true. So regulatory agencies have proven that they can't do the job, and there's substantial barriers to them doing the job. That does not mean that it is hopeless, though. I think that you can implement a framework for security that these regulatory agencies can do that will help in making these devices safer, right? And in doing that, what we have to do is focus on the strength of regulatory agencies. Maybe that's a strong word to put it, because regulatory agencies, maybe some of us might think, that don't have a very strong anything. But let's look at what they do on a regular basis, what they have the infrastructure to support, and let's try and mold ourselves to that. We need to leverage the existing infrastructure to speed up the implementation. If we start from scratch, we'll be here for 10 years trying to make medical devices secure. So we need to make sure that process is speeded up. There's no need to completely blow up the existing process and procedure. Doing that would take too long, and it way overcomplicates things. Might it be better? Sure, it might be better in a utopian situation. But the reality is that that would take a decade to do. So what can we do in the meantime to make things better? What can we do to adapt the current process to address the concerns quickly without making a major shakeup? We also have to be exceptionally cost conscious, right? No regulatory agency right now has the money or the ability to get money in any country to be able to we're going to branch off and create a security regulatory body that's going to make things better. That's not going to happen either. There's 4 steps that I have down here. And the first one is going to focus on the process and procedures associated with addressing security issues, right? Look at a company like Google or Microsoft. They have a process. Somebody comes to them and says, I found a vulnerability, and here's how you can replicate it and validate it. And it goes to a team of people, they go through and validate it, and then they have a process that they look at in classifying it, in assigning it man hours and priority to see how quickly it can get patched. Do they need to do an out-of-cycle patch? Is their PR team going to need to be involved if it's big enough? Is their legal team going to be involved if it's big enough? They can do this at a very rapid pace because they have a process. They have a mechanism, they've thought about it, and they use it and practice it on a very regular basis. Medical device companies don't, right? When I did my presentation and tried to contact Medtronic to let them know that I found this vulnerability, I couldn't get a hold of them. Department of Homeland Security called their CEO, and the CEO didn't call them back. And one of the reasons is, after talking to them, is they said, we weren't prepared for this. We never thought in a million years that somebody would call and say there's some vulnerability on our device. So because they didn't have a process, they didn't have a process, they didn't have a procedure, they didn't know what to do. So they did nothing, which turned out to be pretty bad. Now in that time, in the year since then, they've developed an entire process and procedure and even a C-level executive to handle all security problems and privacy concerns about medical devices. And they've substantially improved in that way, and they've developed processes for that. So how would this work with a regulatory agency? Well, one thing you could do is verify that the company has a plan for how they would fix a device if a flaw was discovered, right? In the example I gave earlier, I can't apply a firmware update. Why not? Well, I never thought I would need to. Well, maybe you should think about that. In the process of getting approval, maybe that should be a question that's asked. Can you apply an update? Can you fix a problem if it came up, right? Do you have a process? Do you have a procedure? Do you have a flow chart of what's going to happen when somebody calls and says, hey, I found a problem with your device? Quite often, companies never consider this, and they're in an impossible situation when a flaw is discovered. And we have models for this. We have business continuity, right? Every one of us goes through very boring business continuity meetings to find out, okay, something bad happens. How can we fail over? How do we make sure our data is protected? How do we get the business back up on our feet? And you go through drills. You go through practice, right? Everybody knows what to do when that happens, hopefully. We can do the same thing with vulnerabilities, right? Importantly, regulators are good at this, right? Process and procedure and due diligence is what regulators do. There's a structure around that. There is an infrastructure to support that. They know how to evaluate that. And generally, they do a pretty good job of it, right? They can validate to make sure that you have done your homework, that you've done your due diligence, that you have a process and procedure in place. So this would not be a stretch for regulatory agencies to do. Action number 2 would be to clear up the process and procedures for patches and updates, right? The industry, the medical industry, the health industry is paralyzed by this right now. And it's paralyzed from lack of guidance, right? We don't know what to do. Just recently, There was a hospital that had a problem with an MRI machine because McAfee antivirus was installed. And they don't know if they can update it or patch it because of this. And they're completely deadlocked. They don't know what to do, right? Because they have no guidance. The vendors don't know what the regulators are going to do. The regulators say, yeah, I don't know, why don't you do it and find out what happens? That's not good guidance. So generally, it freezes people up, right? So the regulators in the industry need to give guidance for how to deal with patches and updates, right? So ideally, I think this process should take less than 90 days, right? If you have an update to your software that runs on an MRI machine from Acme, that process should take 90 days to go through the approval. The FDA should amend the PMN process for software updates. So you say, I've gotten this device approved, I need to make an amendment to that approval that says, I'm updating this library because this vulnerability was found, or this feature was added. And that should not mean that the device goes through the entire approval process again. It goes through a shortened process, which does not take that long, right? And this already exists. Amendments for these changes, amendments for making vendor changes already exist. So this, again, builds on the concept of you're already doing this, apply that same concept to software, apply that same concept to an embedded computer system. The Medical Device Directive should outline a process for updates, right? They should say, these types of updates should be applied, this is how you should go through the update process to make sure the vendor approves of it. Action number 3 is a little bit more technical. From a testing standpoint, wouldn't it be useful to identify the libraries and DLLs that are used by a medical device? In my mind, you break this down into 3 categories. Category A are libraries that are provided by the vendor as part of the install and are only updated by the vendor. All right, so you install the software, these are the packages, these are the libraries that are used by the software to do what it needs to do. Category B libraries would not be provided by the vendor, but are used by the software, right? That are updated by the commercial operating software, not by the third party. So your Acme's MRI software might need to use a library from Windows to be able to display menus, to be able to do all the things that generically are done inside the operating system. So the software is identified as using these libraries, they're important to it, and they use it. And Class C libraries would be everything else, right? The software doesn't use them, so they're not directly or indirectly touched by the software. This allows IT staff to make better determinations of risk on operating system patches. If you see on Microsoft Tuesday that one of the libraries updated is the one that the Acme MRI software uses, you know that you probably need to do a little more testing before you apply it to that machine. Whereas if all the libraries are in the C class, or there are no libraries in the B class, then you have a little bit more confidence that you can streamline your testing with it in that system. Most critical operating system patches have zero impact to the medical device software, right? So when you look at supercritical patches that you're really worried about because somebody can break in with them, the ones that I've seen when I've pen tested medical devices and hospitals and medical environments, are patches that have nothing to do with that software. And the staff, the IT staff, the hospital says, we don't patch those systems because we were told never to patch those systems by the vendor. This is very dangerous, exceptionally dangerous, right? I've heard stories from other pen testers of doing pen tests on systems with laser scalpels that use Windows. And they metasploited the box while it was in process of doing surgery, right? That is not what we want to have done, especially if you're doing that on a box that hasn't been patched in 3 years, right? You have stability concerns, right? Those things should not happen, but they do, so we need to act on them. So being able to identify what libraries are being used by these softwares, I think, is a big key component. And I don't think it would be that hard. I think the vendors would be able to say, These are the libraries being used, and I bet a creative soul probably could create a tool that shows what libraries are being used by the software while it's running. That would be a tremendous help to letting us know what the risk level and the level of testing that needs to be done on these types of devices. So like I said, you might have an example of an Acme body scanner that runs Windows 2010 server. Class A DLL might be the body scanner DLL that's in the software directory. A Class B DLL might be a USB driver that Windows has in the System32 directory. A Class C DLL would be one that would be everything else, right? So you might have an Internet Explorer DLL that the software doesn't use at all, that you could update and know that wouldn't have an impact on the system itself, right? And this defines the scope of the patches, right? It's not necessarily perfect. Could you patch the Internet Explorer DLL and the machine becomes unstable and the medical device is unusable? Yeah. But our job is to determine risk level, right? There's always a risk of that. We know that. We know how to control for that and how to advise based upon that. But what we don't have is the information needed to make those decisions. So by having this type of information, we can say what the level of risk is with a greater certainty. The fourth action is to the requirement of having a third-party test of the medical device as part of the approval process. Right? This is already being done by other agencies, especially in the US. The FCC outsources RF testing to other companies. They don't do it themselves because it's more cost-effective and you can have multiple vendors do it outside of that. So you give your device to the FCC does their thing with it, then they send it off to a company to do the RF testing, to see if it's on frequency, to see what the harmonic distortion is, things like that. I'm saying that we should do this with medical devices. There are lots of consultant companies out there. There are lots of companies that do this type of business, right? Medical device vendors should be able to pick their own security company to do their testing. And what they would do is submit the report and the documentation in the approval process for review, right? And we don't want we don't want the regulators to evaluate the security. It should be outsourced to experts. You want to get your own team of people to do it based upon your criteria for hiring a vendor like that. I see them submitting full reports as well as remediation for items found to be insecure. It's very similar to how pen tests work, where you say, we were able to pop these 3 boxes, we were able to get in and do these types of things. Our remediation suggestion is that you patch these boxes, put a firewall in front of them, and make these adjustments to your IDS rules. Right? You could do the same thing with medical devices. Here's an example of an Acme body scanner again. Right? It goes through a big vendor for a security test, for a pen test, for analysis, and they find a SQL injection flaw in the login. And this allows attackers to enumerate the users and list the password hashes for any user that can use the MRI or the body scanning machine. The vendor's action is to apply input filtering to prevent the mangling of the username and password field, to do some input validation. And then the third party goes back through and tests to confirm that their solution remediated the problem. All of this does not need to go through a regulatory body, right? But it should go on the record and reviewed. They should submit this as part of their process to say what the medical device does and that they've done their due diligence and that they've done their work. Is this a perfect solution? No, not at all, right? It does not mean that your device is guaranteed to be secure. Just like a pen test does not guarantee your network is 100% secure and that nobody could ever break into it. But it does take huge strides to safer devices. It does mean that the level of defense is much higher. The barrier to getting into that device and to doing harm is much greater, just like it is when we model our network. Just when IT staffs have somebody come in and do a scan of their network, to do a pen test of their network, to evaluate their network for security flaws. We know that doesn't make it perfect, but we do know that it's going to make it a whole lot harder for anybody trying to get in and trying to do bad things. The conclusion to all this is that vendors can start this process right now, and some of them already have. Get medical devices reviewed by third-party security companies, right? You're a medical device vendor. You are not a security vendor, right? Go out and get experts. Go out and find companies that you're comfortable dealing with at a cost point that you can afford, and get them tested. Get them tested and fix those problems, and then make that part of the process. So when the FDA comes up to you, or the European Union body comes up to you and say, hey, what happened at this medical device that got broken into that we saw at Black Hat 2013? You can say, well, we did a pen test. We went out and got experts. We looked at all of these things and we remediated everything that we could find. It's not perfect, but it's definitely the best we could have done. Whereas right now when this happens, they go, yeah, we never thought that would happen. Sorry, and we can't fix it. That's what we need to get away from. Also, go through business continuity-like process for vulnerability disclosure, right? Call your lawyer, call your legal counsel team, and say, if this were ever to happen, what kind of things would you be concerned about? Can we prepare for this in any type of way? Go to your engineers and have a process with your engineering team of how to validate that process, how to validate any vulnerabilities that come in, so that way you know that they are a problem or not. Get your PR team involved. Quite often, with medical devices, this becomes a story in the media, a big story, right? And it's not one that is beneficial to medical device companies. So you want your PR team to be able to respond, to be able to know how to respond, not just to say, we're working on the problem, I think, right? They should be prepared to answer those types of questions. They should be prepared statements that they know what to do, because they've talked with the lawyers and engineers and other executives on what they would do in the event that this happens, right? All of this can be practiced. All of this can be planned out ahead of time. And follow that plan when it comes time to do it, right? What good is it if you have a disaster recovery plan and when a disaster happens you go, we're not going to follow that plan, we're just going to wing it. That's pretty much not how it works, and you're pretty much setting yourself up for disaster when you do that. Do what you practice, because that's what you've thought out. In pressure times, you don't have the time to think about things. You don't have the ability to see things, and you're not afforded the time to make long process decisions. That's why you plan ahead. That's why you do it ahead of time, is so that way you can spend a lot of mental energy on it, so when the time comes, you already know what to do. That's what practice is about. In the future, very shortly, I'm going to be, and I'm in the process of talking to the FDA, talking to people in the European Union about, I'm going to lose this again, about adopting this framework, about what they think would work in this, to see if it's possible to make this happen right now. So those four things are going to be what I'm going to be bringing to the FDA, what I'm going to bring to them and say, I think these are really good ideas. I do not think you should try and tell these medical device companies how to fix them, how to be secure, because you don't know how to do it any better than anybody else, right? But there is something you can do to address this problem. That is what the GAO report said. They said, you should do something about it, but we're not going to tell you what. As somebody that works in the field, as somebody that has worked in the IT field and on computer systems for 15 years in security, I think that these things would substantially help make these devices safer, and I think it would substantially help our job as IT practitioners to make the environments we work in safer. And I think it can be done without being a total pain in the ass, without having all of the junk that we have and the things that we make fun of when we're at Black Hat and at security conferences about things like PCI, about things like regulatory process that we all know are a joke. But if you knew that the medical device that you just had implanted in your body was pen tested by a company that you recognized, and that the FDA looked at it, and then they went through and remediated the things that were found, I bet you'd be a lot happier and feel a lot better about having that device implanted into your body. And I think that as somebody with one of those medical devices, that's what I would want. If my children had to have a medical device, that's what I would want. So that's what I'm going to be pushing for throughout the year. I am very accepting of criticism and suggestions to how to do that process, how to enhance this, maybe make additional steps, because I think that as a community, there can be a lot to be added. A lot of these things came from the presentation and the comments and the feedback I got from people from the presentation in 2011. With that, I thank you very much. I hope you enjoy the rest of your day. If you see me in the hallway, if you have any questions or if you want to talk, I should be around for the rest of the week. Thank you very much.